In the last class, we stopped at this question, so I think the writing part wasn't completed. So please just copy this question, then we'll move on to the uniform circular motion. Okay, please just copy.
Okay, ma'am. Done, ma'am.
All right. So see, let's move on to the topic uniform circular motion. See, in
Ma'am, I
uniform.
didn't write this. Now only I joined class.
Okay.
Now only I came from school.
Okay. Yes. That's right. Text me,
Just 2 minutes.
Hamza. Okay. Just text me that.
Just 2 minutes. Okay,
Okay.
ma'am. I'm done.
Okay. See, coming to the uniform circular motion. So there are few conditions that you should know when we talk about the uniform circular motion. See, two kinds of velocities have been introduced in our system now. First one is what? One is and one more thing, please open the cameras, all of you. So one of them is the linear velocity, other one is the tangential, other one is the angular velocity. These were the two velocities that we studied in the last class, correct? Now see, when you talk about uniform circular motion, there are certain criteria that are present that makes a complete uniform circular motion. Okay, uniform circular motion, you will find it a bit questions in your projectile motion also. So from there also the same data is taken. So first is that magnitude of linear velocity is constant. Linear velocity, which will be acting tangential. The magnitude of this linear velocity, this will be constant. Like if it is 3 meter per second. So at every point that I take, here if I choose this point, here if I choose this point, at every point, if this is 4 meter per second, this will also be 4 meter per second, this will also be 4 meter per second. Means magnitude of the linear velocity remains same, okay, without any acceleration, because see, the magnitude is remaining constant, so you will not have any acceleration in the system. Second point, direction of linear velocity can change. Now, in a circular motion, why can the direction change? Because the direction of the linear velocity is given tangentially. Okay, by a tangent, it is given. So, see, every point that I'll mark on the circle, the direction of the tangent will be different. This is this tangent. So till the time my magnitude is same and the direction is changing, so we'll just keep the direction getting changed. That's okay for us. We need to have the magnitude constant. That's a prior condition for the uniform circular motion to be executed. So first is magnitude of linear velocity is constant. You don't have acceleration, and the direction of the linear velocity is allowed to be changed because it is tangential, and every point the tangent will be different. So direction can change. But when you talk about the angular velocity, these were the 2 points about the linear velocity, its direction, its magnitude. For angular velocity, everything has to be constant. The magnitude also, the direction also. Because there is no case of tangent in the case of the axial vector, right? See, if I talk about the angular velocity, let's say I have a certain value. Here at the center of the axis, inside is this cross symbol denotes the inside sign. Okay, so this shows that magnetic field, the magnitude of the angular velocity, this is inside. So when I drop the symbol omega, this is the angular velocity. Now see what's the value. Let's say some value 5 radian per second. This is fixed. So for 5 radian per second, this shouldn't be variable. It cannot be 5 t square radian per second like this. Anything that is having a variable function. Okay, so variables cannot be there. It should be a constant value, and the direction should also be. For angular velocity, both the things have to be the same. Okay, when we are talking about the angular velocity, its direction, its magnitude, both of them will be the same, constant. But when you talk about the linear velocity, direction, and its magnitude, then see, here the direction can change, but the magnitude remains the same. So only one quantity changes, and that's how you identify whether a uniform circular motion is existing or not. Okay, so just write down this. Then I'll talk about how we write the centripetal acceleration and the tangential acceleration. Please start writing from here.
Done, ma'am. Done, ma'am.
All right. See, let's talk about a little bit about the velocities. When you have the linear velocity, there are two kinds of accelerations will be there in your system. Actually, we have three kinds of acceleration, but from your uniform velocity, from your uniform circular motion, you just have two kinds of acceleration. Okay. So first is tangential acceleration. When do you have tangential acceleration in your system? When the magnitude of the linear velocity changes. Okay. See, two things are occurring. Can occur. No? When do we have acceleration? When velocity changes. Now, what change can be there in a velocity? Because now the direction is separate. It is tangential. So directional part is separate, magnitude part is separate. So when the magnitude of the linear velocity changes, when the magnitude of linear velocity changes. Okay, this is what is the tangential acceleration that comes to the system. We will represent it by AT, and it's very easy. The formula and all, they are very easy to write. And next you have centripetal acceleration in your system. This comes due to direction. The direction that is changing. So here, when the direction of linear velocity changes. Linear velocity changes. So here in your system, the kind of acceleration which you get is the centripetal acceleration. Now a little bit about the tangential and the centripetal, let me tell you. Tangential is very, very easy to remember, though tangential will come again. I'll discuss that. Tangential acceleration is basically rate of change of magnitude of linear velocity. That was its definition as well, when the magnitude of linear velocity changes. So its formula is also this: rate of change of linear velocity, rate of change of magnitude of linear velocity. So here when you write, the formula will be dv over dt, the usual accelerations formula that we tend to write. What is at? This is the tangential acceleration. Okay, this is the tangential
Ma'am, but you said
acceleration.
magnitude of linear velocity is constant.
What? No, this is not related to your uniform circular motion. This is not uniform. Okay, this is the kinds of accelerations that we have in our system. Okay, so this is tangential acceleration. Now see, what is dv over dt? This is the rate of change of velocity. Rate of change of linear velocity. Okay, so this is what your tangential acceleration is. Very easy, directed. What is its direction? It will be directed at the tangential point where your tangential velocity is supposed to be present, like this. So this is what you have as the tangential acceleration. We will do this tangential again, but you should have it written together. Now coming to the centripetal acceleration. Now for centripetal acceleration, it's a little peculiar. Centripetal acceleration will always act towards the radius. Means if my radius is this is the radial path. Let's say this is the center of the circle. So it will be always along this radial path. See, one is tangent, one is along the diameter, one is perpendicular to axis. There can be many dimensions. So this one is acting along the radial path. Okay, this is the radius of the circle. So along the radial, whichever it is, whichever radius of the circle it is. Second condition is the centripetal acceleration is directed towards the center. This is how the centripetal acceleration is written, directed towards the center. And the formula of centripetal acceleration is very easy. Centripetal acceleration is basically v square divided by r. R means the radius of the track and v means its linear velocity. Okay, this has nothing to do with your angular velocity. These two accelerations are coming because of your linear velocity. Okay, because of angular velocity, whatever will be the change, we'll see that later. These two accelerations are coming because of change in the linear velocity. The linear velocity is also existing, it's change. Do one thing, write it till here, then we'll solve the numericals, okay? Please start writing from here.
Done now. Done now. Done, ma'am.
All right, let's move further. So let's practice some numericals from this. Here this says that a body is moving on a circular track with a velocity of 10 meters per second. Now it says radius of the track is given as 2 meters. We have to calculate the angular velocity. We have to calculate the centripetal acceleration. Now see, what is this angular velocity? Angular velocity is different. As I told you, because of the angular velocity, we have two kinds of velocities we have. One is the linear velocity, one is the angular velocity. So yesterday we already talked about the angular velocity, if you remember. Can anyone tell me the formula of angular velocity?
Theta by T.
Theta by
T. The time.
T. Very good. Yes. Theta by T. So see, here it is saying a body is moving on a circular track with a velocity of 10 meter per second. Velocity is given as 10 meter per second. Next it says that radius of the track is given as 2 meter. Now we did a relationship between all these three. Yes, what was the formula which can connect all the three of them? V R omega. There was one formula which we did.
Yes, ma'am.
What was it?
Linear velocity is equal to radius into angular velocity.
Yes, very good. Very good. This is correct. V is equal to R omega. So from here, omega will be equal to V by R. V is 10, R is 2. That makes it 5 radian per second. Okay. Now centripetal acceleration. Centripetal acceleration is what? This is V square divided by R. V square means 10 into 10 divided by R is 2. That becomes 50 meter per second square. See, till the time you don't have angular term in the formula and it's not a term of rotation, you're not going to use radian and all. Centripetal acceleration will be meter per second square. Tangential acceleration will also be meter per second square. Both of these accelerations, see, here also when in your notes you just added that both of these will have the accelerations unit as meter per second square only. Okay. When do we have a different value that we'll study? Like angular velocity was different, angular displacement was different. Okay. Now we'll come to non-uniform circular motion. But first, please write down this question.
Can you please show the before screen? I'll just take a screenshot. Ma'am, I had finished the next part. Done, ma'am. Done. Ma'am. Done, ma'am.
From here, all of you can write.
Done, ma'am.
Done, ma'am.
Done, ma'am.
Done, ma'am.
All right. See, now talking about the non-uniform circular motion. So we just discussed the uniform circular motion. Okay. So when we talk about the non-uniform circular motion, non-uniform means due to which velocity is changing, what kind of acceleration we have in our system. Okay. See, when the magnitude of the linear velocity changes, when it is variable in non-uniform circular motion. See, Aisha, you were asking also that this is the velocity is getting changed. So how do we have it? So that was not a part of uniform circular motion. Here, this is a part of non-uniform circular motion. So when the magnitude of the linear velocity is changing, we get tangential acceleration. The tangential acceleration. When the direction of the linear velocity changes, we get centripetal acceleration. Okay. See, when the magnitude of the angular velocity changes, which wasn't changing in the case of the uniform circular motion, when omega is variable, when omega changes, when this value of the magnitude of the angular velocity changes, you get angular acceleration in the system. Okay, you get angular acceleration. We haven't talked about the angular acceleration yet. So we'll see. So when the magnitude of omega changes means angular velocity changes. We get the angular acceleration in a system. And see, when you have the direction of the angular velocity constant, you don't have any acceleration. No acceleration in this is in this case. So these are the conditions necessary for a non-uniform circular motion. See, everything will be variable this time, except the direction of the angular velocity. In case of uniform circular motion, what was it? Only the direction of linear velocity was changing. The rest were constant. Here, only one is constant. Okay, that is the direction. So this is a condition. We already talked about the tangential acceleration. Tangential acceleration means rate of change of magnitude of the linear velocity. At, this is equal to dv over dt. This is its formula. Rate of change of velocity. This is the velocity. This is the time. This is the tangential acceleration. So SI unit is meter per second square, and see how will we figure out its direction. Direction is very simple. It will be parallel to the linear velocity. Linear velocity is tangential, so you will have the tangential acceleration also situated along the tangent. So remember, this is always situated along the tangent. That's why we call this as the tangential acceleration. SI unit is meter per second square, direction is tangential to the circle. Now you write it till here, then I'll start with angular acceleration. Write it down from here.
I'm done.
Ma'am, can you scroll down? Ma'am, scroll up.
Up this part.
Done. Ma'am, done.
Mom, this tangential acceleration and the one we wrote before is same, right?
Yes, this is the same. It's just the heading that is written separately because it's a new acceleration for you. That's why it's the same acceleration.
Okay.
Done?
Yes, ma'am.
Okay. The angular acceleration, the way we did, no? Initially, that we have angular displacement. When this changes with respect to time, we have angular velocity. Now, when angular velocity changes with respect to time, you have angular acceleration in our system. This is like what you did in kinematics. What did we study? Then you have displacement. When displacement varies with time, we get linear velocity. When linear velocity varies with time, we get acceleration. So just their analogs are there. Your linear displacement becomes angular displacement, linear velocity becomes angular velocity, and linear acceleration becomes angular acceleration. So formula will also be very simple. It is represented by the symbol alpha. This is equal to omega divided by t. The angular velocity divided by time. That is its formula. This is what? This is the angular acceleration. This is the angular velocity. And this is the time. Now see, similarly, for angular acceleration also one thing, the SI unit before we begin, SI unit will be radian per second square. See, radian per second square. Like you have meter per second square. So here also radian per second square. Now look here, when we are talking about the angular acceleration, similar to the linear angular velocity, here also you can differentiate it d omega over dt, or you can calculate the change in omega by change in time. Both of the formula can be used. You can differentiate it if you're calculating instantaneous. You can calculate the change in average when you have to find out for a duration. Okay, let's see this question. It says linear velocity of a body changes from 10 meter per second to 30 meter per second. Means initial velocity is given as 10 meter per second. Final velocity is given as 30 meter per second. On a circular track, radius is not given, time is given to us. That this is 10 seconds. Okay. Now, Ikra, you tell me the first part. What's the change in velocity? It's the easiest question. Change in velocity. Yes, Ikra. Initial velocity is 10 meter per second. Final is 30. Yes, Ikra. You are not audible. Ikra, mute yourself, please. Not able to hear her. Ikra, please just type your answer. Your voice isn't coming. Please just type it. Change in velocity. Answer to the first part, that is the change in velocity. Yes, Ikra, what's your answer? You don't even have to apply any physics in this.
Final
Yes.
minus initial.
Yes, final minus initial. Now your voice is coming. So final minus initial means how much is it?
20.
30 minus 10, that is 20. Yes, very good. V final minus V initial is 30 minus 10, which is equal to 20 meter per second. That's it. That is the change in velocity. Now, coming to tangential velocity. Hafsa, can you tell me what should be written for the tangential velocity, tangential acceleration? Change in velocity we have. We already have the change in velocity. What should be written next?
Difference velocity like v is by t,
V by
dv by dt.
delta V by T. Delta. See, we write dV, but if the value is not infinitesimally small, you can use delta V also. Okay, dV over dt is there. So this becomes delta V by T, which is 20 divided by 10. That is 2 meter per second square. Okay. Angular velocity is clear to all?
Yes, ma'am.
Yeah, ma'am.
Okay, all right. Please write this. Then we'll practice more questions.
Ma'am, can you scroll up for 1 second? Thank you, ma'am. Done.
Done, ma'am.
Okay. Rest of you have also written?
Yes, ma'am.
Okay. See, this says angular velocity of a body changes from 5 radian per second to 25 radian per second. It means initial angular velocity is given as 5 radian per second. Final angular velocity is given as 25 radian per second. In time is given as 5 seconds. So it says first part says calculate the change in the angular velocity. Yes, Aisha, what's the change in the angular velocity?
Final minus initial,
Final minus initial, that is
20 radian
20.
per second.
Correct. So this will be final minus the initial value, which is equal to 25 minus 5, that is equal to 20 radian per second. Now, yes, Sanidhi, angular acceleration.
Ma'am, do you want the answers or should I say the equation also?
Anything?
Yeah, ma'am. Angular velocity by time, which is 20 by 5,
Yes.
should come out to be 4.
Delta omega by t. So this is equal to 20 divided by 5, which is 4 radian per second. Now, question, let's see if we can try down this. It's a very small, easy question. See, in uniform circular motion, you have very easy way. Write it.
Done, ma'am.
Others also. Okay.
Yes, ma'am.
Okay, so see, this question says angular velocity of the body changes from So angular velocity, omega initial is 5 radian per second. Omega final is given as 25 radian per second. It says in 5 seconds, this is the change in velocity. It increases from 5 to 25. It says radius of the path is given as 10 meter. You have to calculate the tangential acceleration. Now see, for the tangential acceleration, we require velocity by time. Velocity is not given, time is given. For velocity, we know using omega and r, we have the relation r omega. Now you don't have one value of omega, there's a change given. So we are going to also put the change. Change in omega is C final minus initial. So 25 minus 5, that makes it 20 radian per second. That's the change in the angular velocity, delta omega. Now, V will be equal to R 10 into delta omega, which is equal to 10 into 20, that is 200 meter per second. Now I have the linear velocity with me. See, what did I did not have? I did not have the linear velocity, and tangential acceleration is all based on the linear velocity. So I didn't have the linear velocity at the first. So what we did, we have taken V is equal to R omega. Now omega is also not given directly, that one value is just put. So we calculate the change and then we take R into delta omega, whatever is the change. So that gives us the linear velocity. Now tangential acceleration will be, linear velocity is what, 200 divided by 5, which is equal to 40 meter per second square. Okay. Is this clear? Is this whole topic clear to all? Easy? I hope you're not finding it difficult.
No, ma'am.
All right. Please write this. Ikra, you getting?
Ma'am,
Ikra,
but in
please.
assignment we'll find it difficult.
Assignment you'll find difficult. No worries. We'll discuss the difficult questions. But yesterday's assignment was very easy that I have given. Have you opened it?
Ma'am, it wasn't uploaded before class.
Yeah,
I couldn't
ma'am.
find it on the
I-
portal.
Yeah, now
It
only
was
it's uploaded.
what?
I couldn't find
Now
it
it's
on the portal
uploaded.
before class.
You couldn't find it before the portal? It has
Yes,
not been
ma'am, for
uploaded.
me also.
No, ma'am, it hasn't been updated even now.
Okay. Though I'll just talk and confirm this. I'll just share this. See,
No, ma'am, it's
yesterday's
uploaded now.
is it
It's there.
uploaded?
Yes,
It's there?
ma'am.
For me, I can't see.
You still can't see, Aisha?
No,
Hafsa, you
ma'am.
can see?
Yes.
Yes, ma'am.
Okay. I'll just check. Who all are not able to see? Aisha and Sanidhi. These two. Okay. Yesterday's assignment, you Hafsa, now check the questions. Are the questions easy or difficult?
I'll check, ma'am.
Ma'am, I can see it now.
Sanidhi, it's visible to you also. Aisha,
Yes,
let's just wait for a few more minutes.
Okay, ma'am.
See, assignment questions are tough. One reason is that, see, in the class, we cannot start with tough questions. We'll have to practice the easy questions in the class so that your basics are cleared.
No,
Tough
ma'am.
questions
Actually,
are
the
given.
reason is that in class your question language is so easy, but in assignment,
Yes, the language part is there. It's tough because most of the questions are from the NCRT, and NCRT has a very tricky language. So that's why it is given as assignment, so that you at least attempt it once, and then your doubts are taken in the class. Okay. So yes, assignment. But yesterday's one you try, Hafsa, today. In the next class,
okay,
we'll discuss. You will definitely find the questions of yesterday's class easy, and in fact today's assignment also, because these are the questions that I have given from myself, not from NCRT or somewhere. So you will not find them difficult. So try them, okay?
ma'am. Okay.
Others have also done?
Yes, ma'am.
Okay. See, the way we had a relationship between the linear velocity and the angular velocity, similarly, there's a relationship between the tangential acceleration and angular acceleration. It's very simple and easy. Look, the formula will be the tangential acceleration is, it was r omega, this is r into alpha. That's it. The direction of the tangential acceleration will be tangent to the circular track. Okay, this will be tangent to the circular track. While r will be the radius, alpha will be the angular acceleration, and it is the tangential acceleration. So just like we had the relationship between all the three, this is what we have. Now see, this part is important because you get most of the questions from this. See, the tangential acceleration is like this, tangent to the surface. Centripetal acceleration is towards the radius, along the radius towards the center. So when you are asked about the total acceleration in non-uniform circular motion, see, it's like you have two vectors, one vector pointing like this, one vector pointing downwards, making an angle of 90 degrees between them. So the net acceleration is given by the root of AT square plus AC square. Basically, since angle is 90 degrees, so what do we have? When the angle is 90 degrees, you use the parallelogram law. A square plus B square plus 2AB cos theta, we write. Now in this case, cos theta will be what? Cos 90 degrees, and cos 90 degrees straight away 0. So net acceleration in this case will come out to be 0. Got it? So total this is also not difficult. It's just that both the accelerations are combined together. Like, let me discuss one or two questions, and yeah, then we will come back to the laws of motion part. This will complete the basics of circular motion. Let me do this question. See, body is moving on a circular track with speed of 10 meters per second. So this is given as speed. Okay, speed is given as 10 meters per second. Radius of the track is given as 2 meters. If its velocity changes at the rate. Now, class, this is very important. Can any one of you tell me what is this given to? What is this 2 given as? Read the question and tell me what is this 2 given as. Out of all the things that we've said.
Tangential acceleration.
Very good. Tangential acceleration. See, rate, velocity is changing at the rate, means the magnitude is changing, and that is provided to us. Also, if you're getting confused, because sometimes I'll tell you, like Hafsa, you were saying also that sometimes the language of the questions become tricky. So here it can be tricky in tangential. So what you do, best part, you see the units. Meter per second square, nah, it can't be velocity, it will be acceleration only. So angular acceleration will have radian. It could be either centripetal or tangential. Now rate, it is because of the rate of change of velocity. That is the tangential one. So tangential acceleration is given as 2 meter per second square. Basically, the rate of velocity dv over dt is given as 2 meter per second. Now first part says centripetal acceleration. Centripetal acceleration.
Can it be like angular acceleration?
This won't be angular acceleration because the unit will be radian per second. Radian will come. Meter cannot come. Okay. Centripetal acceleration is v square divided by r. V is 10 into 10 divided by 2. This is 50 meters per second, while the tangential acceleration is 2 meters per second square. Per second square. Now it says total acceleration. So second part, total acceleration means under root of AC square plus AT square. Now this calculation you'll have to perform plus 2 square under root, which is 2500 plus 4, which is 2504. Now please just check. I think this will be around 48 point something. Let me just see the calculator. What is its value? This is under root, because see, under root 25, we know it is 50. So this should be 2504. Yeah, this is 50.0399 something. See, this is anyway, this was negligible, this one. So you can write this almost as 50.039. This is the accurate answer, but you write it as 50 meter per second square. That is also right. Okay, so these are the basics of the circular motion. And today's assignment also I'll give from my side. So don't worry, today's assignment will also be easy. I'll not take the already typed assignments from my end, I'll give you. Because if you see the assignment that you must have received, these are typed ones. These are not from the those purple assignments. I think this is what we have today for yesterday's work. From the PDF typed PDF you must have received. So is it?
Ma'am, we didn't check yet, but we will check afterwards.
What?
We didn't check yet, but I will check afterwards.
Okay, you haven't checked. Okay, that's
I
not
still didn't give mine.
You still haven't got Aisha?
No, mom, it's not in the portal.
I'll tell them. Okay. Plus, all of you, please write down all these parts. I'll just pray and come. Okay. Otherwise, the time will go here. Just tell me one thing. Did you write it till here?
Yes, mom.
Yes, ma'am.
Yeah.
I've written it till here. Okay. Please start writing. From here, I'll just have to offer one prayer, Maghrib's prayer. Otherwise, time will go off. Okay. So please write. I'll just come back in a few minutes. Yes, done, all of you?
Yes, ma'am.
Okay. I hope you have written all of these. If there's anything you want to write, please let me know. Just a minute. Okay, talking about the dynamics of uniform circular motion. Now we come back to our chapter, laws of motion, which we were studying. Okay, so this part was the part related to the laws of motion, the circular motion part. Now this part is back to the laws of motion. Some topics are there. First is a very, very important topic, centripetal force. And please open your eyes and ears and understand this topic. It's not so difficult, but it's just that this will be used throughout your 11th and 12th. See, centripetal force is a new kind of force for you. You haven't studied before. And once again, please open the cameras, all of you. Don't put the cameras off in the classes. So, yes, coming back to the centripetal force. Centripetal force is not actual force that is existing. Like when we talked about the frictional force was a real force which was present. Okay, frictional force was existing in your system. There are other forces also that are present, that are real, actually existing, like the gravitational force. You can really feel the pull of the earth. You are able to experience the gravitational pull of the earth. So all these are what? These are real forces that are existing. Then what kind of force is the centripetal force? See, centripetal force is that force that is provided by any force. Like, see, centripetal force is a force if any force acts along the radius towards the center, where the centripetal acceleration was acting along the radius and towards the center, then we say this particular force is providing the necessary centripetal force. Centripetal force is what? It's a force that pulls object towards the center. It will pull the objects towards the center of the circle, whatever is this uniform circle. So it will pull it towards the center. But this is not a real force that is present like the other forces. One or the other forces will be existing, that if any force acts in this manner, that will be providing the necessary centripetal force which we see. Like, I'll give you a few examples. Some of it will be new for you, some of it you must have heard of. See, when the sun is there, earth is present. Now earth is revolving around the sun. So we'll study in the chapter gravitation that there is a gravitational force, which we have already done in the dimensional analysis as well. So we have the formula capital G m1 m2 by r square. This, what is this? This we'll study in the gravitation chapter. So what is this? This is the formula of the gravitational pull of the sun on the earth. Now, what happens is the sun exhibits the gravitational force along the radial path and towards the center. So if it is acting along the radius and towards the center, and a complete circular motion is also existing, means this time this gravitational force will provide the necessary required centripetal force. Similarly, if I give you one example, this you will study in class 12. The first chapter will be this only, about the electrostatics, which will be very interesting. So you have the nucleus present, electrons are revolving around the nucleus. This, at least the basics you already know, especially from the chapter structure of atom. Now electrons are held through the nucleus via electrostatic forces. They have a formula K Q1 Q2 divided by R square, which you need not study this year. Now this formula of force is the formula of the electrostatic force. Now, when the electrons and protons are there, electron is also revolving around the nucleus in a circular fashion, right? So, when the electrons are revolving around the nucleus in a circular path, and there is a force that is along the radius towards the center. Now, we know that it's the electric force. So, whatever is the necessary centripetal force required to move the electron in the circular path will be provided by this electrostatic force. Or one very classic example that you have to study this year itself in this chapter, when vehicles are moving over a circular track, especially in the hill stations. So what happens when the curved turns are there? If the centripetal force is not provided, vehicles have the tendency to slip out. That's why there's a speed limit also given over hilly areas, that this must be the minimum speed and or the maximum speed which should not be exceeded. So what happens is when you will resolve this part, we will see in detail. When you will resolve the components and all the forces, you will see if the car has the tendency to slip outside, friction force will have the tendency to come inside, because friction force will act opposite to the motion. So in this case, the frictional force, which is mu n, will provide the necessary centripetal force required, because the frictional force will be acting along the radius and towards the center. So do you get it? What I mean to say is that the centripetal force is not a real force like all these forces, gravitational, electrostatic, friction. What is the centripetal force? Centripetal force means it's like a demand. Okay, it's like a requirement that has to be fulfilled by any force, so that the body remains intact in a circular motion. So the force which is required to change the direction of the velocity, it provides a centripetal acceleration and it acts along the radius towards the center. See, centripetal acceleration is v square divided by r. Now, F is equal to ma. The formula of centripetal force is quite easy, mv square by r. Formula will be simply mv square by r, which you will use a lot. Like if I am able to give you an example of electrostatics in class 11th, now imagine how much of this part will be required in your class 12th. So see, you don't have to worry about class 12th, but you have to make those topics very strong, which will be utilized later. Like I focused so much on vectors, and still the class students of 12th, there's so much they stuck up in the vectors part, because here you have frictional force, there you'll have electrostatic force, but the calculation of vectors will be the same. So just have few things and make the base very strong. Now see, here also the SI unit will be Newton, because it's a force. CGS unit will be dyne. But see, if you want to write, see, V square can be written as omega square R, omega square into R square. So if I put it here, I'll be able to get M omega square R square divided by R. That makes it M omega square R. So this is also the formula which you can use as a modified formula for the angular rotation given. So in all these cases, I can say gravitational force, this is providing the centripetal force, mv square by r. So you can just equate all these things. Here also, this is providing mv square by r. Here also, this is mv square by r. And now, if you remember in the dimensional analysis, when we did a question, there was a question which was related to this force is directly proportional to mass, velocity, and radius. So what were the values? So this is what we were getting, k mv square by r. So this is the actual formula of it. And let's see a question based on this. See, this says a body of mass 10 kg is moving on a circular track. Now, what all things are given? Mass is given as 10 kg, radius of the track is given as 5 meter, and it is moving with a velocity of 2 meter per second. Very easy formula based question. Centripetal force is mv square by r. So, see, all these questions that were there in between was just practice them today. They were very easy questions, but they were present. I wrote them in between so that you know how to apply the basic formula. At least you should know how to apply the basic formula. Now we'll move on to the rest of the questions then. So m v square will be 2 into 2, radius is 5, that makes it 8 Newton. Okay, so this is the centripetal force, and centripetal force, why is it so important and why did I focus so much on it? The reason is that centripetal force will not be given to you like this. The way you have the frictional force, you can identify by seeing whether a smooth surface is there or a rough surface is present, because that's not a real force which is present. Centripetal force, you will have to identify. How will you identify it? By seeing whether this force is acting towards the radius or along the radius and towards the center or not. That's the best trick for it. If it acts, definitely it is providing the centripetal force without any double thought. So is the centripetal force clear to all?
Yes, ma'am.
Okay. Please write it. And if you have any doubts from this, please clarify. You may have questions from here. Write it, and we will do another similar force before coming on.
In centripetal force,
Yeah.
friction force is there.
any force, Hafsa, any force, that is any real force which is existing. Like you have the gravitational force. You have, if I say a block is put here, so energy will be acting like this. So the center will provide the friction, the necessary centripetal force. If the frictional force is acting, then that will provide any force that is there. If it is acting along the radius towards the center, it provides the centripetal force. Means because of this, the body is in the circular motion. Okay.
Okay, ma'am.
Please
Ma'am,
write it.
in ninth grade, there was this example of a rock with a thread and we like move it. Is that also centripetal force?
Rock and thread motion in a vertical circle. Yes, the force that is acting towards the center is the centripetal.
Okay, ma'am.
Okay.
Yeah. Done now.
Yes, ma'am. Was done?
Yeah, ma'am.
Okay. Okay, this question was also left. Okay, you can write this together. Let me just discuss a bit of centrifugal force. See, centrifugal force is opposite to centripetal force. Means opposite in the sense that centrifugal force will be the force that will pulling away the body. See, I'll give you a very basic example. All of you must have sat on the merry-go-round, the swing, at least when you were kids. So if you don't pull the handle properly, if you don't stick to the handle properly, don't take and don't have a very good grip, what happens? You tend to fall outwards. You don't fall inwards towards the handle. You tend to fall outwards. That's because the centrifugal force is acting. So magnitude wise, it's the same, and theoretically also it's the same. That some force will be providing the necessary centrifugal force, and it's not an actual force. Okay, same thing. That's why it's written also pseudo force. But what's the difference? It is acting along the radius. See, radius path is only there, but this will be away from the center. Centripetal was towards the center, centrifugal is away. But don't think these are action reaction forces. These are not action reaction forces, centripetal and centrifugal. When you see the magnitude, it is mv square by r. When you see the direction, they are just exactly opposite. So it appears as if these are centripetal opposite action reaction. So it acts in a rotating frame. It's a pseudo force. Direction I've already discussed, and it's not a reaction of the centripetal force. Just have this in mind. Now, okay. This let me tell you. See, there's a safe limit. What is the safe limit? We'll discuss what is the value of the safe limit when there's a turn. Okay, and vehicles are present. So there is often a warning speed that is set up. That this is the speed limit that has not to be crossed, especially in the circular tracks. If at your places you must have gone, or hill stations have you gone, or those who are from India, have you traveled here in India, the north part of India?
I'm from
Hills.
Kashmir.
You're from Kashmir, Aisha?
Yeah.
Okay. All right. Then you must be knowing this perfectly. The altitude and all the changes. So
Yeah.
especially Kashmir and all, yes. So you would understand the best out of all of us. See, when the turns are there, the car will have a tendency to skid away outside. So what happens is all the cars or all the trucks, all the bikes, every vehicle has a particular safe limit. Now we'll calculate that safe limit, but we will calculate it by seeing which force is providing the centripetal force, and if not, then due to the centrifugal force, it will be thrown out. Car skids away. This is known as skidding. When the vehicle moves out of the circular track, this is known as skidding. So a safe limit is decided. Now, what is the safe limit that we'll talk later? But please copy down this part quickly.
Ma'am, can you explain this force again? I don't understand.
What, Hafsa?
Ma'am, this next force.
Centrifugal. This one.
Yeah, ma'am. This force. Sam, can you explain this again?
Okay. You want me to explain this again? No, I thought you just want to write. See, centrifugal force means, see, centripetal force was the force that was acting towards the center, pulling the objects towards the center. Like Earth is rotating, so Earth is not moving out of the space or its orbit because centripetal force is pulling it. And which force is providing centripetal force? Gravitational force, like this. Centrifugal force is the one just opposite. It pushes the body out of the circular track. So that's why we say this is its path, means along the radius. This is the along the radius, but it will be away from the center. So see, the best example is what we can relate is with the merry-go-round thing or anything that is moving in a circular path, especially the merry-go-rounds when you stand on it or if you're not holding the rails properly, you leave the handrails, you will be thrown out. There was a possibility that you could have been thrown inside also, but you're always pushed outside because centrifugal force acts in that case. Okay, so that this is the force that acts. It's a pseudo force, means some other force will provide it. Okay,
Ma'am, what is the direction of pseudo force here?
this is the pseudo force away from the center. See, if a body is there, this is a body which is there here, let's say. So see, along the radius will be this. This is the radial, and away from the center. So this will be it. Okay.
Okay, ma'am.
One more thing. See, you must be confused about the this pseudo force part. No, this is because this acts in a rotating frame. Like for centripetal force, it's not necessary that your frame should also rotate. Centripetal force is not a pseudo force. If any car is standing stationary also on a circular track, so that will be provided through a centripetal force. That's why it is standing stationary. But centrifugal force only acts in the system when this also rotates, when my this frame is also rotating. That's why I gave you the example of merry-go-round. You are there on the merry-go-round and that merry-go-round is also rotating. But in case of centripetal force, we didn't have the frame to move. You know, don't have the road to move or proton to move or the sun to move. Okay, so that's why this is a pseudo force, because now this is, see, rotating frame means non-inertial. Got it? Is the confusion clear?
Yes, ma'am. Ma'am, that's the question I was about to ask you now, but you said answer.
Okay, all right.
Ma'am, what is safe limit?
Safe limit means the maximum velocity. Like if I say 40 kilometer per hour, is it? That's not so much. Actually, it is around 30 kilometer per hour for vehicles here in India at least. So if it is 30 kilometer per hour for the circular tracks, so that becomes the safe limit. Means if I am driving at the speed of 35 or 30, 25, I'm safe. If I cross that, the car can skid because of the radius and everything. Okay, that is the safe limit. We'll calculate this. This is the safe limit. Maximum velocity by which body can move on a circular track. Okay.
Okay, ma'am.
Now, two derivations are there. Three actually. Bending of road, banking of road, and bending of cyclist. Bending of cyclist is a very easy one, very short one. But two are there which we'll have to do. That we'll complete in the next class. So just quickly write this. Aisha, Hafsa, and Sanidhi. Other students are joining. And when you three write, just text me done. Then I'll start your class, Mariam and all. Please wait, Mariam. Aisha, Hafsa, and Sanidhi, you please wait. Okay, if it's
Done,
done,
ma'am.
you can leave. Okay, we will meet.